All right, for the first part of your test, you will not be using a calculator that has a log or an ln button on it. So that's no graphing or scientific, just one of the little 4-function colored calculators. So for the first couple, it says rewrite each logarithm using the change of base formula. And so for the first one, it says use a base of 10. So for a change of base formula, remember we said it's like there's an invisible line right here. And so the 1.86 is going to go in my numerator and the 6 is going to go in my denominator. So then this can be any base. And for the number 1, they ask us to do a log base 10. So remember that for the log base 10, it's the common log. So you don't have to write the base of 10. You can just write log. And we know that's log base 10. All right, then for number 2, same thing, only this time they wanted a base of e. So again, like an invisible line here, the 38 goes in my numerator and the 5 in my denominator, and the base that we want is e. And remember, log base e is abbreviated ln. So that would be ln 38 over ln 5. And then for number 3, it said use a base of 5. All right, so I'm going to, again, put the 1.9 in the numerator and the 4 in the denominator. And then we've got our base of 5, and they could give us any other base that they wanted to. All right, then the next thing we're looking at expanding and condensing logarithms. So for expanding, remember that when you have the log of 2 things that are being multiplied, you can break that into 2 separate logs that are being added. So we actually had 3 things that were being multiplied, so we're going to break that into 3 separate logs where each of those logs is being added. Then we have a property that says if you have an exponent that you can move that out in front of your logarithm and make it a coefficient that we would multiply by. And so that's the last thing that we've done here. For number 5, so that same property we were just using, when you have an exponent, you can move it out in front of the log and multiply by it. All right, then when you have the log of 2 things that are being divided, you can break that into 2 separate logs that are being subtracted. Now, remember that 5 is being multiplied by this whole thing. So when I break this into 2 separate logs that are being subtracted, that 5 is going to be multiplied by each of them. So again, when we're dividing, we subtract. So we would have x divided by y cubed means subtracting y cubed. And then the last thing is that exponent can be moved out in front of the log. Now, notice that the 3 only applied to the y. It didn't also apply to the x, so that's why we only move it out in front of this log. And we already had the 5 there, so 3 times 5 is giving us that 15. All right, then for number 6, we have 2 things that are being multiplied, so I can break that into 2 separate logs that are being added. So here's the z to the 5th and the square root of x. Additionally, we know that square root of x is the same thing as x to the 1/2. Remember, the numerator is your exponent and the denominator is your index. So square root of x is the same thing as x to the 1/2. So now I can take my exponent and move it out in front of my logarithm, and same thing here, take my exponent and move it out in front of my logarithm. All right, then for condensing into a single logarithm, and if we can, go on and simplify that down as far as possible. So if we have 2 separate logs that are being added, we can combine them into 1 log that's being multiplied, and we actually had 3 things that were being added, so we're going to be able to combine all 3 of those into a single log that's being multiplied. Also remember that when you have a number out in front of the log, that can be moved to be the exponent. So this 2 out in front of this log base 7 right here of z is going to become our exponent. And then because we had 3 things being added, we can combine them into 1 where they're all being multiplied. All right, if we look at the next one, again, the number out in front 3 is going to become our exponent. And then we have 2 logs that are being added, so we can combine them into a single log by multiplying. So 2 cubed is going to be 8, and 8 times 8 is going to be 64. Now, when we get here, this can be simplified down further, and we always want to give our log in simplest term. So we could say 4 to the what is equal to 64. So we want to get our bases the same and set our exponents equal to each other. So I'm going to rewrite 64 as 4 to the third. So now my bases are the same. I can set the x equal to 3. All right, then for number 9, again, when we have an exponent, a number out in front, we're going to make it an exponent, and then same thing here, this number out in front becomes an exponent. And then when you have two logs that are being subtracted, you can combine them into a single log that's being divided. So now we want to simplify this. Remember, if you have x to the 12th divided by x to the 2nd, when your bases are the same and you're dividing, you subtract your exponent. So 12 minus 2 would give us x to the 10th. All right, so then we want to switch to solving equations. So remember that if your bases are the same, then you can set your exponents equal to each other. So I want to try and rewrite 81 and 243 with the same base. All right, so if I do 3 times 3 is 9, times 3 is 27, times 3 is 81. So 3 to the 4th would be 81. And if you multiply that by 3 just one more time, 3 to the 5th would be 243. When you have a power raised to a power, you multiply. So we're going to do 4 times 3n is 12n, and 4 times negative 3 is negative 12. So now my bases are the same, and I can set my exponents equal to each other. So I'm going to set the 12n minus 12 equal to 5. So add 12 to both sides, and then divide both sides by 12, and we end up with 17 over 12. All right, then for number 11, these bases are already the same, so I don't have to get them the same. I can just go ahead and set my exponents equal to each other. So 3n minus 3 equals negative n minus 2. So let's add the n to both sides. So 4n minus 3 equals negative 2. Then add 3 to both sides, and we'll have 4n equals 1, and divide both sides by 4, and we'll get n is equal to 1/4. All right, for this next one, again, my bases aren't the same, so I want to try and get them the same. So I can rewrite 36 as 6 squared. So 6 times 6 is 36. And then 6 times 6 times 6, 6 cubed is 216. So when you have a power raised to a power, you multiply. So 2 times 3 is 6, and 2 times negative 3k is negative 6k. So now my base of 6 is the same, so I can set my exponents equal to each other. So 6 minus 6k equals 3. So let's subtract the 6 from both sides, and we'll have negative 6k equals negative 3. And then divide both sides by negative 6, and we'll get k is equal to positive 1/2. All right, then for number 13. For this one, we're moving into a logarithm now, and we had a property that said, if you had the log base a of x equals the log base a of y, then x has to equal y. So in essence, if this log and base are the same as this log and base, and they've told me these two things are equal, then that means what I'm taking the log of here has to equal what I'm taking the log of here. So we can say v is equal to 6 minus v, so add v to both sides, and we'll have 2v is equal to 6, divide both sides by 2, and v is equal to 3. Now, with a log, remember that you cannot take the log of a negative number or 0. So we need to check these and make sure that our answer is not an extraneous root. So if I plug in 3, that would be the log of a positive number. That's fine. And then 6 minus 3, that would be the log of a positive number as well. All right, so then for this next one, I've got log base 8 of something is equal to log base 8 of something. So that means that those two things have to be equal to each other. So 5n plus 6 equals n minus 2. So we'll subtract n from both sides, and then subtract 6 from both sides, divide by 4, and we'll get n equals negative 2. So if I take that negative 2 and I plug it back in, 5 times negative 2 is negative 10, plus 6 is negative 4. That would be the log of negative 4. You can't take the log of a negative number. That's not possible. If I plugged it into the other side, negative 2 minus 2 is negative 4. You can't take the log of a negative number. So that means that that is not a solution. If that's the only answer that I got, then that means there is no solution. All right, look at this next one. So for this next one, I don't have a log on one side is equal to a log on the other side as I have the past couple. I have two logs that are being added. So we can use our condensing rules like we were using a few moments ago. And we can say that if you have two logs that are being added, you can combine them into a single log that's being multiplied. So 6 times 3x is going to be 18x. So now we've combined this into one single log that's easier to work with. So when we were solving our logarithmic equations, we said we don't like logs. We want to get rid of them. We want to switch them to an exponential. So we're going to switch this to its exponential form. That would be 7 to the 2 equals 18x. So 7 squared is 49. So 49 equals 18x. Divide both sides by 18 and we'll have 49 over 18. And again, if I take that 49 over 18 and I put it right here, 3 times 49 over 18 is going to give me a positive number, so I won't be taking the log of 0 or a negative number, so that solution will work. All right, then for 16, I've got two logs that are being subtracted. So remember that when I have two logs that are being subtracted, I can combine them into single log by division. So this is going to be my numerator, negative x, and this is going to be my denominator, 6. So here's my single log with negative x divided by 6. All right, so again, now that I have a log, I want to get rid of it. I don't like logs. I want to switch them to an exponential. So if we switch this to its exponential form, that would be 2 to the 4 equals negative x over 6. So 2 to the 4 equals negative x over 6. So 2 to the 4th is 16. So now we've got 16 equals negative x over 6. Multiply both sides by 6 and then divide by a negative 1 and we'll have x equals negative 96. So if we take that negative 96 and we plug it back in, negative times the negative 96 would be positive 96. So I am taking the log of a positive number, so I can do that. All right, then for 17, I'm back to an exponential again. So I want to get my bases the same so I can set my exponents equal to each other. And so I'm going to rewrite 10,000 as 10 to the 4th. So now I can set negative v equal to 4 and v is equal to a negative 4. For number 18, again, I need to get my bases the same so I can set my exponents equal to each other. So I'm going to rewrite 32 as 2 to the 5th. So now I can set the 3p plus 1 equal to 5. So let's subtract 1 from both sides and divide by 3, and we've got our solution. All right, for number 19, they already gave me my bases equal to each other. So all I need to do is just set the exponents equal to each other. So we'll subtract 1 from both sides and divide by 2, and we'll get k is equal to 1. All right, for this next one, when your base is the same and you're dividing, you subtract your exponents. So that's going to be 2 to the negative 3p minus 3p. So that would be 2 to the negative 6p, right? So now I need to get my bases the same so I can set my exponents equal. So I'm going to rewrite 16 with a base of 2. So that would be 2 to the 4th. So I can say negative 6p equals 4. So divide both sides by negative 6, and that'd be negative 4/6 or negative 2/3. All right, for this next one, remember when your bases are the same and you're multiplying, you add your exponents. So we're going to say negative 3n plus negative 2n plus a negative 3. So negative 3n plus negative 2n plus negative 3. So negative 3n and negative 2n is negative 5n minus 3. And so our bases are the same, so we're just going to set those exponents equal to each other. So let's add 5n to both sides and then divide both sides by 2, and we'll get negative 3/2. So that entire first part, we would be using only a calculator that does not have log or ln on it. So just an add, subtract, multiply, or divide. All right, so then you would turn that portion of your test in and you would pick up the second portion. And for this second portion, you're going to use a graphing calculator.